Hello everyone, welcome to the video lecture of this course Finite Element Method. Myself Dr. Onol Ranjan Sengupta. I am an assistant professor in Mechanical Engineering Department of JIS College of Engineering, Kolkata, West Bengal. So I will discuss this subject with all of you. Okay. So basically the name of the subject it is Finite Element Method. Okay, so what is this Finite Element Method actually? So it is actually a numerical method to find the approximate solution of the partial differential equation. So now all other methods, numerical methods like finite difference method, finite volume method, then meshless method. So all these things will be discussed in brief, but we will concentrate on this finite element method and what is the difference in between those numerical methods. All will be discussed in details. Next, why we will use this finite element method in the different design and analysis. Then what is discretization, what is the node element. So all these different things will be discussed in details. And what is pre-processing, then solver, post-processing, that means the various steps of this finite element method, then the different steps of this finite element method. So all these different things and the different numerical techniques to solve the various problems of this finite element method, we will discuss this analytically. Okay, so let us start this lecture. Okay, so the name of the subject is actually the finite element method, and in our college we are having the course code as ME703C. The total contact hours is actually 36. That means we will have total 36 lecture for this subject. The credit is actually 3 for this subject of this course. Now there are different course objective for this subject. So what are those objectives of this course? These are to introduce the concept of mathematical modeling of engineering problems to the students and to appreciate the use of finite element method to a range of engineering problems. So these are actually the course objective. That means we will learn some mathematical modeling. We'll try to solve some partial differential equation by this finite element method to find some approximate solution of this partial differential equation, and we will see how to use this finite element method in a range of engineering problems. There are some course outcome, 4 different course outcome of this subject. That means when the subject or this course is completed, then the students they will be able to understand the fundamental theory of this finite element method. Okay, so the next course outcome it is the develop the ability to generate the governing finite element equations for systems governed by partial differential equations. Okay, so we will study the different governing equations of this finite element method, and we will try to solve some partial differential equation using this method. Next, use of the basic finite element methods for structural applications using truss, beam, frame and plane elements. Okay, so for all these different structural elements like truss, beam, frame or plane elements, for all these cases we will use the basic finite element method to solve different numericals. And the last course outcome it is the to analyze of the finite element method and comparing result with the finite element analysis package like ANSYS. So there are actually different softwares by the help of which we can solve these finite element method problems. So among those different finite element methods, we are having this software package ANSYS in our college laboratory. So we will try to use this finite element method problems in the software, and we will simulate different finite element method problems, and we will try to compare those results with the real life values. Okay, so these were the course objective and course outcome of this subject, finite element method. Now let us come to the syllabus. We are having actually 6 different modules for this total 36 lecture. So the module wise the syllabus is given here. So in the first module, the topics that we will cover, these are the historical background of this finite element method, then the relevance of the finite element method to the design problems, then application to the continuum, then discretization, then matrix approach, matrix algebra, then the Gaussian elimination, then the governing equations for continuum, classical techniques in finite element method, in short it is written as FEM, then weighted residual method, then Reed's method, and Galerkin method. So in this first lecture, or the first module actually, we are having this syllabus. So here we will start from the very basics of the finite element method or finite element analysis. Then we will study its historical background, different steps or different phases of the finite element method process. Then some matrix calculation we will study there, some governing equations for the continuum concept, then different methods like weighted residual method or Rayleigh-Reed's method or Galerkin method. All these things we will study, and we will discuss different numericals in this first module, that is introduction. Our next module is named as one-dimensional problems. So the syllabus under this module, it is the finite element modeling, coordinates and shape functions, with potential energy approach, element matrices and vectors, assembly for global equations, boundary conditions, higher order elements, and shape functions, applications to axial loadings of rods, extension to plane trusses, bending of beams, and finite element formulation of stiffness matrix and load vectors, then assembly to global equations, boundary conditions, and solutions and post-processing, and some example problems. So this is the syllabus under the one-dimensional problem, that is the second module of this finite element method. So here basically we will study the one-dimensional problem of this finite element method, and we will discuss different matrix concept regarding this finite element process, and a lot of numericals which are somewhat lengthy. Those lengthy numericals analytically we will discuss in this second module. Next we are having our third module, which is named as two-dimensional problems. and under this we will study that scalar variable problems in this third module. So in this third module, the syllabus is like the finite element modeling, then CST element, then element equations, load vectors and boundary conditions, assembly, application to heat transfer, and some numerical examples. So all these things we will study under this third module. It is the two-dimensional problems and scalar variable problems. So we will discuss in details what is the CST, then different load vectors and boundary conditions, then application to heat transfers. Actually this finite element method, it can be classified in two different parts. One is structural and another is non-structural. So in case of structural, we will study all this beam, truss, load vectors, then bending of the beam. So all the structural part we will study in the structural analysis, and in case of the non-structural analysis, we will study the thermal and fluid flow in case of this finite element modeling, the heat transfer also. Next we are having our fourth module. Now it is the two-dimensional problem but with vector variable problem. Our last third module was the two-dimensional problem but with scalar variable problems, but in this fourth module we will study the two-dimensional problem using the vector concept. So here the syllabus that we are having in the fourth module, it is the vector variable problems, then elasticity equations, then plane stress, plane strain, axisymmetric problems, formulation, then element matrices, assembly, boundary conditions, and solutions examples. So this is the syllabus under the fourth module of vector variable problem in case of the two-dimensional analysis. So some basic things like stress, strain, all these things should be clear to us, and this elasticity concept that we have studied in the strength of materials. So all these things should be very clear to us, like what is stress, what is strain, what is the difference in between the stress and pressure, because both are having the same SI unit. So the basic fundamental concept of the stress, strain, then elasticity, elastic limit, Hooke's law, all these things that we have studied in our strength of materials course, all these things should be revised and it should be very much clear to us. Next, in number 5th module, we are having the isoparametric elements for two-dimensional problems. Now in this 5th module, we will study the natural coordinates, isoparametric elements, then 4-node quadrilateral element, then shape functions, element stiffness matrix and force vector, then numerical integration, stiffness integration, displacement and stress calculations, some more examples. All these things we will study in this 5th module. Okay, so this is the syllabus for this 5th module, that is for isoparametric elements for two-dimensional problems. Okay, and our last module, it is the computer implementation. So here the syllabus is the pre-processor, processor, then post-processor, the discussion about finite element packages. So this last module, it basically deals with the simulation using the ANSYS software. So in this ANSYS software, we will see that in case of the structural analysis, there are actually three different phases which are actually written here: pre-processor, processor, and post-processor. Now for any kind of analysis using this finite element method, there are actually three different phases. First one is the pre-processing. So here in this pre-processing, what we will do, a finite element mesh is actually developed to divide the given geometry into subdomain for mathematical analysis. And the material properties actually we also apply there, and the boundary conditions. So what is this mesh? What is the discretization? What are the different subdomain in case of the element, node, and how to put the material property, and what is the boundary condition? Why will we use this boundary condition? Where to put this boundary condition? All these things will be discussed in the pre-processing part. Next we are having the processor, or it is also known as the solution. So in this second phase actually the governing matrix equation, these are derived, and the solution for the primary quantities, these are generated. So the governing equation for this finite element method we will discuss regarding that. The solution for the primary quantities, how to generate all these things, it will be discussed. Lastly, we are having the post-processing part in the software simulation. And this last phase, we will check the validity of the solution generated. Means we must check the validity of our result. Next, the examination of the values of primary quantities, such as the displacement, then stresses. All these things should be examined properly, whether our result is up to the mark, it is almost accurate or not, or if it is not accurate, what is the error percentage involved. So all these things will be discussed in this post processor part. So this is the these are the 6 different modules, and under these modules we are having this syllabus for this finite element method subject. Okay, so all these different modules will be discussed in total 36 lectures with all of you. Now these are the different textbooks and reference books which are there in our curriculum. We are having total 4 textbooks and we are having total 2 reference books. So the first textbook, it is by R.D. Cook, Malkas and Plesha. The name of the book is Concepts and Applications of Finite Element Analysis. It is a Prentice Hall publication. Second textbook is Chandru Patla and Belegundu. So they are the authors, and the name of the book is Introduction to Finite Elements in Engineering. It is also a publication from Prentice Hall of India. Third book, it is written by C.S. Krishnamurti, and the name of the book, it is Finite Element Analysis, and it is Tata McGraw-Hill Publications. The fourth book is K.J. Baith, and the name of the book is the Finite Element Procedures, and it is also Prentice Hall Publications. Now these are the 4 different textbooks. We are having 2 different reference books for this course, Finite Element Method. The number 1 reference book, it is named as the Finite Element Method, its basis and fundamentals. The writers are Sienkiewicz, Taylor and J.Z. Zhu, and it is from Elsevier publication. And the second reference book's name, it is an introduction to the finite element method, and written by J.N. Reddy, and it is of McGraw-Hill Publications. So these are the 6 different books. Out of that, 4 are the textbooks and 2 are the reference books. So you can study, and you can opt any of these books. These are available in your library, and or some soft copy in internet also these are available. So you should study the concept of this finite element method from any of this book along with the video lectures. So this is the lesson plan for this total 36 video lecture. So module wise and lecture wise this lesson plan is shown here. So in the first module we are having total 8 different lectures to complete our syllabus. The lecture wise the topics and the syllabus it has been covered here. Okay, so in this first module, that is introduction, we are having total 8 different lectures, and this module actually basically deals with the basic concepts and various methods of the finite element method or finite element analysis. Next, in the second module, we are having 8 different lectures. There we will study the one-dimensional problem, and this module it actually focuses on the application of stiffness matrix for the beam element. So the use of the stiffness matrix to solve and analyze the different problems regarding the truss, beam, frame, all these things will be discussed in details in this second module. Next we are having the third module where we study the application of the CST element in finite element method. So in this third module we are having total 4 different lectures. Next we are having the fourth module. In this fourth module we will have 8 different lectures where we will study the vector concept. In the earlier module we have studied the scalar concept, and in this fourth module we will study the vector concept for two-dimensional method. We will understand the shape function and the strain displacement matrix for the axisymmetric element in this module. So in 8 different lectures all these things will be discussed in details, like the shape function, then strain displacement matrix for the axisymmetric element, on the nodal coordinates for an axisymmetric triangular element. So all these things will be discussed in details. Next we are having our fifth module. Here we are having total 6 different lectures, and the isoparametric concept it will be discussed on those 6 different lectures. So this fifth module, it actually deals with the concept of isoparametric elements, and several matrix equations in this regard will be discussed. Next, and the last module, it is the software analysis part. So here we will study the application methods of various software packages of FEM. Basically, we will discuss the ANSYS software by using which we will go through some simulation for this finite element method, and all the pre-processing, then processing or solution, and the post-processing part for this ANSYS software simulation will be discussed in details with all of you. So as this is our first lecture in the introduction part, so let us start some of the basic concept of this introduction to the finite element analysis. So what is this finite element method actually, or finite element analysis? So as I have said earlier that this finite element method it is actually a numerical technique or numerical method to find approximate solution of partial differential equation. So different partial differential equations will be solved analytically in this subject to find the approximate solution. So it was actually originated from the need of solving complex elasticity and structural analysis problems in civil, mechanical and aerospace engineering. So actually, as I have said earlier, that this finite element analysis can be classified in structural and non-structural part. So actually, in a structural simulation, the finite element method actually helps in producing the stiffness and strength visualization. Means we will be able to see in the software simulation the stiffness and the strength. It actually also helps to minimize the material weight and its cost of the structures. Okay, so this finite element method, it allows the user for detailed visualization and indicates the distribution of stresses and strains inside the body of a structure. So suppose when there is a beam element, so when different loads are applied on this element at different points, so in that case how the load distribution will be there, the generation of stresses and strains inside the body, all these things will be clearly visualized when we will discuss the software simulation through ANSYS. Now, as we are having a lot of finite element software, so these are actually powerful but complex method or simulation process. It is complex. So these are actually meant for professional engineers with the training and education, and it is necessary to properly interpret the result. Otherwise, there may be some error percentage in the result that we will get ultimately after the simulation. Several modern finite element method packages, these are actually there with, and their specific components are there such as fluid, thermal, then electromagnetic and structural working environment. The finite element method actually allows the entire designs to be constructed. The computational domain for any design and analysis, it will be drawn first. After that, it will be refined and optimized before the design is manufactured. Okay. Now, this finite element method software tool, it has significantly improved both the standard of engineering design and the methodology of the design process in many industrial applications. And the use of this software, it has actually significantly reduced or decreased the time to take the products from concept to the production line. So to get the precision level or to get the accurate result for various design and analysis of several engineering products, we should take the advantage of this software analysis, by which we can optimize and refine the design before it is manufactured, and which also reduces the time significantly. Now, actually in this diagram, one complex shape it is given and it is a domain. So this is our computational domain which is given here, and this typical element, the nodal point, all these things are actually written here. So what is the use of all these things? What is this meshing or discretization? All these things will be discussed in details. So what we do actually, some breakdown of the original complex shape, it is shown here. So here actually what we do, a body or a structure in which we will carry out our analysis, we subdivide it into smaller elements of finite dimensions. And these are actually called the finite elements. So after breaking down the total complex shape into smaller elements, then the body is actually considered as an assemblage of these elements, which are connected at a finite number of joints. And those joints, these are known as the nodes or nodal points, which we can see here by arrow sign it is given. And the properties of each type of finite element is obtained and assembled together, and which are solved as a whole to get the final solution. So this is the process actually that we do in all the analysis of the finite element method. There is a historical background on where it started. This finite element analysis, it can be actually traced back to the work by Alexander Renikoff and Richard Courant. So Renikoff actually introduced the framework method in which a plain elastic medium, it was represented as collections of bars and beams. So these pioneers share one essential characteristic, that is the mesh discretization of a continuous domain into a set of discrete subdomains, usually called elements. So these elements and nodal points or the nodes concept, it has been discussed just now. Now after that, in 1950s, the solution of large number of simultaneous equations, they became possible because of the digital computer. Next, in 1960, Ray W. Clough first published a paper using the term finite element method. Next, in 1965, the first conference on the finite elements, it was held. After that, in 1967, the first book on the finite element method, it was published by Zinkiewicz and Chang. Next, in the late 1960 and early 1970, the finite element method, it was applied to a wide variety of engineering problems. After that, in 1970, most commercial FEM software packages like Abacus, Nestran, ANSYS, etc., these were originated. Now, interactive finite element programs on supercomputer lead to rapid growth of CAD systems. Next, in 1980, the algorithm on electromagnetic applications, then fluid flow and thermal analysis, these were developed with the use of finite element program. Engineers can evaluate ways to control the vibration and extend the use of flexible deployable structures in space using the finite element and other methods in 1990s. Trends to solve the fully coupled solution of fluid flows and structural interaction, biomechanics related problems with a higher level of accuracy, these were observed in this decade, that is in 1990 to 2000. So these are the references, and this is actually our first lecture of this course, finite element method. So today in this lecture we have seen the course objective and course outcome of this subject, finite element method. After that, we have discussed the syllabus comprising of the 6 different modules. What are the topics, what are the things we will study in those different 36 lectures. After that, we have seen the lesson plan. Then we have discussed in details the concept of the finite element method, how it was originated, what is the concept of this element and nodal point, why it is called as finite element. So this concept of this finite element analysis or finite element method, it is discussed in details. After that, we have seen the historical background, starting from 1941, Alexander Renikov, up to this current decade. Step by step, we have seen the development of this finite element method by various scientists. When the first paper was published, when the first book was published, when the first international conference it was conducted, when the structural part was added, when the non-structural part was added. So all these things we have seen while studying the historical background of this finite element analysis. So this is the end for this lecture. In the next lecture, we will study the different numerical methods, then different steps of this finite element method, different phases of this finite element method, and the concept of the degree of freedom. So all these things will be studied in the next lecture.